Namaste friends, welcome to Rhchemistry. In today's JEE MAIN 2020 bits from Nta Abhyas app, solid state chapter I am going to discuss. It's a very important chapter for JEE exam point of view. So already I have done with NEET solid state. So please refer that video also, so that definitely you are going to get some help from that also. Right? So in this part, so very important calculation of density and calculation of the finding the formula of that particular compound when the such type of question is given, that we'll see. See, first question is in orthorhombic unit cell, the value of ABC are given. Molecular mass is given, density is given, the number of formula units per unit cell they are asking. Formula unit is nothing but they are asking about Z, remember. They are asking about Z. Right? So we'll use the formula. We know that Z is equal to formula is, remember, density into A cube into Na divided by molecular mass. Right? So here density is given, no problem. So density is, I will write it here. So 3.3 gram per cc. And Na is also given 6 into 10 to the power 23. And that we know. And important, A cube is not given. See, A cube means whatever A is given, that is cube. It is wrong, remember. It is not ABC given. They have not given edge length. This is the one edge A, then B, then C. So hence remember, we know that volume, you can see orthorhombic crystal will be like this. You can see it on the screen. So in the orthorhombic crystal, A into B into C if I make, then I will get the volume. Hence remember what I will do, 4.2 into 8.6 into 8.3 I will do into 10 to the power. See here centimeter cube is there. Angstrom unit is nothing but 10 to the power minus 10 meter. So if I convert into centimeter, 10 to the power minus 8 centimeter, minus 8 cube, it is 10 to the power minus 24 directly I have written. Right? So divided by molecular mass is 155. 155 you got. Molecular mass 155 is given. Right? Now you simplify this. Now one thing is very simple. 10 to the power we don't need because it is only Z. So definitely it will get cancelled. Only we have to know the answer start with which digit. That is very important here. So that will do. So here one thing is, you can see it here. Here 4.2 into 8.6 into 8.3 I have to make. Right? So just like this, I will take it as 4 into 9 into 8. So 4 into 9 into 8 I will consider for this. Right? You are going to get it as, so 8 9s are 72. Right? 72 4s are 288. So you are going to getting as 288. Right? So I will write that 288 into 6 into 3.3 is nothing but 6 3s are 18. So 0.3 is there. 6 3s are 1.8. So 0.3 into 6 is 1.8. So around 20 you will get. I will write 20 divided by 155 I will write. So this I will write as 288 into 2 is 576. Correct? 576 divided by, I will write 150. Simplification 150. Now we know that 150, 15. Right? So 15 4s are 60. Right? 15 4s are 60. So 15 40 is 600. So nothing but 4 should be the answer. Nearest to 4, that is 4 should be the answer. Like this is enough. Because in approximately you can get it 4. The answer is C. Now crystal made up of XYZ. Y occupies all octahedral whites, Z occupies tetrahedral whites, X forms FCC packing. If all particles along one body diagonal are removed, then the formula of the crystal they are asking. So here also you can see, I have shown you FCC, how that octahedral and tetrahedral whites will be present. You can see it on the screen here. Right? Generally what happens is octahedral whites present in the edge center and body center, and so this particular tetrahedral whites are present at the corners, remember. So hence, in this particular case, first I will write, see, X occupies FCC means first I will write X4, FCC number of particle. In 4, remember, octahedral whites are is equal to same number. So 4 only. So Y I will write 4, right? X4, Y4. Then Z is equal to, in this particular case, see, XZ occupies tetrahedral whites. Tetrahedral whites means is equal to 8. It is before this particular condition. X4, Y4, Z8. Now you can see if all particles along one body center is removed, body diagonal is removed. When the body diagonal is removed, remember, definitely two corners are removed. From the body diagonal, it means it is a corner like this, remember. So this corner and this corner is removed. Two corner particles are less. Addition to that, here one tetrahedral, here one tetrahedral. Two tetrahedral whites are less and one octahedral whites are less because center particle is also removed. So one octahedral white is removed. So total, remember, two corner. So two tetrahedral whites and one octahedral whites are less. One octahedral whites are less. Now we will calculate. See, before this, remember, 4 particle was there. Now it becomes, so first it was 8 corners and 1 by 8. Now 2 corners less means 6 corners into 6, 1 by 8. Right? So plus 3 I will make, because plus 3 means face center it is corner particle, corner. Face center 3, here it was 8 into 1 by 8 plus 1. So 3 plus 1, 4 was I have written here, FCC. But here face center 3 as it is, but two corners are less, hence I have written 6 by 8 plus 3. So this become equal to, right? So 8 3 is a 24, correct? 24 plus 6 is 30. 30 divided by 8, it is nothing but 15 divided by 4 you get. So hence I will write X 15 divided by 4 and Y. 4 was there, tetrahedral, octahedral whites, but now 1 is less, 3. Now Z, 8 was there but 2 less, now 6 here, right? This is 15 by 4, 3, 6. If you simplify, you get 15, 4 3 is a Y 12, 4 6 is a Z 24, right? Now you simplify, 3 5 is a 15, right? X 3, 3 4 is a 12, Y 4, 3 8 is a 24, X 3, Y 4, Z 8 is the answer. X 3 5 is a, sorry, 5 is a, so X 5, 3 5 is a 15 divided by 3. So X 5, Y 4, Z 8 is the answer. So the answer for this question is D. Like this you have to solve. Now, here, strontium crystallizes in FCC unit cell with edge length A. It contains 0.2% Frenkel defect and another crystal of strontium contain 0.1% Schottky defect. Density of the solid with Frenkel defect is DF and with Schottky defect is DS. Then it is actually very simple question. So 0.2, 0.1% everything is given. But remember, whenever 0.2 Frenkel defect, 0.1 Schottky defect is there. Whatever the percentage of Frenkel defect present in the crystal, it will never change the density. Because density changes only in case of the Schottky defect. Remember, density decreases. Hence, remember, always Frenkel defect and Schottky defect if it is present, because of Schottky defect density decreases, because of Frenkel defect it remains same, means overall Frenkel defect density increases than the Schottky defect. Hence the answer for this question is DF more than DS. B is the answer. Then CSCl crystallizes in body-centered cubic lattice. If A is its edge length, then which of the following expression is correct? Very important in this particular concept, which will help you in solving so many problems, remember, in a solid state about BCC. Now in BCC, very important, body diagonal. See, which of the following expression is correct? They are asking that one. We know that in case of this BCC, so you will write it as body diagonal. Body diagonal. See, this word, it will comes under only for body, this BCC, not FCC, or for FCC we will consider face diagonal, right? So for SSC there is no diagonal like that. But here body diagonal, because in BCC we know that at the center one particle will be present. So that BCC CSCL structure also you can observe in the screen here. This BCC CLCL structure also you can see it on the screen, where so at the center you can see one particle is present. That is, you can say CS plus. Plus will be present at the center and negative Cl minus present at 8 corners of the unit cell. Now, if you consider that particular body diagonal like this, one is here, one is center, one is corner, correct? Here one R minus, here one R minus, and here 2 R plus, R plus. Total radius, what we will write? Total radius, what we will write? Root 3 divided by 4a. Correct? Root 3 divided by 4a we will write. But this radius is having how many? So 4r here. Correct? 4r here. You can see that. Right? So totally when you write, when you remove that only R plus and RCL minus out, right? Then definitely the answer of this particular question become 2RC plus 2RCL minus are there. Correct? You see here. 2RC plus R, 2R minus 2R plus. 2 common out. 2 common out. So what I will do, at that 2 I will take it this side. Actually body diagonal is nothing but, so dense D is equal to root 3 by 2A. D is nothing but RC plus RCL minus. Hence answer for this question will be C. So definitely you'll understand that in the diagram you can see that 2R plus 2R minus is equal to root 3A. So RC plus RC minus is equal to root 3A by 2. So this is the answer for this. Whenever body diagonal is given, like this you have to calculate R. Everything will be given. A given, CL minus is given, RC plus, CS plus if they ask. Use this formula, root 3A by 2. Remember that. So this is, remember, 4R by root 3 is edge length. So this only I have written like this. In packing efficiency derivation, what we will do? A is equal to 4R by root 3 we will write. Correct? So root 3A by 4. So that is also correct. But when they ask body diagonal, RC plus RC minus CL minus is equal to root 3A divided by 2. Remember this formula. Now, another important type of compound, the problem, remember, which was given in the Nta Abhyas app. In this case, here you can see thallium aluminum sulfate twice XS2O is BCC with edge length A 1.22 nanometer. If density of the solid is 2.32 gram per cc, then the value of X is atomic weight of thallium aluminum sulfur oxygen H is given. Now, in this particular case, how to solve this particular question? So how? First what you have to do, you have to calculate the molecular mass of the total this particular substance by using density formula. Right? So by using density formula, density is equal to Z into M A cube into Na. In this case we will get M. M is equal to D into A cube into Na divided by Z we will get. So calculate M. So after calculating M, so total is equal to M. Correct? So now you calculate the weight of TL, AL, SO4 twice by using all this. Into X into water is 18 is equal to this mass. So what is X we will calculate later. So that is very simple formula, but only this mathematical calculation is required. Now I will calculate. M is equal to density is how much? 2.32 into. So A cube. A is given 1.22, correct? 1.22 cube into nanometer converted into centimeter because it is in centimeter. Nanometer is 10 to the power minus 9. Centimeter 10 to the power minus 7. So 10 to the power minus 7 cube. So minus 21 I will write directly. Correct? So into Na is 6 into 10 to the power 23 divided by m. Molecular mass is, you have to calculate, density is given actually, density is given, no? Divided by z. BCC is there, z is 2. So when BCC is given, z is equal to 2, correct? Now the calculation you see here, 1.22 cube is how much? See, if you calculate 1.22 cube, so not much difference, remember. So 1.22 cube is equal to, always equal to 1. 1.22 cube is equal to around 1.89, like that you will get. Nothing but 2 I will consider it is. So after considering 2 here, I will cancel this 2 and this 2 out. Approximately it is enough. This 2 and this 2 I will cancel it out. Correct? Now what is left? That is important. 6 into 2.32. 6 into 2.32 is 6 2s are 12. Right? 6 2s are 12. 6.3 is a, so 1.8. 13.8 like that you will get. But already here 1.89 I have considered it is 2 and I have cancelled it out. Hence 13.8 I will consider it as 13. 13 into 10 to the power minus 21 plus 23 means 2 is equal to 1300 you got. Correct? Approximately. So 1300 you got. Now this 1300 is equal to mass of the whole molecule. Correct? What is the mass of thallium aluminum sulfate twice? You calculate. So 204 plus 27 plus, so 32 into 16 into 4 twice you have to do. So you do that within a fraction of second, 120 to 30 seconds you have to tell that answer, because we don't have much time. You are going to get it as 423 mass. For this 423 you will get, so into X into water is 18. Correct? Water is 18. Right? Now we will write 18x is equal to 1300 minus 423. Almost 900 I will write. 900 I will write. X is equal to 900 divided by 18. So 18, 5s are 90. So 50 is the answer. 50 nearest to that is 47. So the answer for this question is C. The metal M crystallizes in BCC with cell unit cell edge length 400 picometer. The atomic radius of the M is. So in this case, so edge length 400 picometer. So atomic mass of the atomic radius of the M they are asking. This is BCC. Correct? If this is BCC, remember we know the formula R is equal to root 3 A divided by 4. Same formula, root 3 A divided by 4. Right? So root 3 divided by 4 into A is 400 picometer. 400 into 10 to the power minus 12. Here actually minus 12 not necessary. Minus 12 meter. Yes. 400 into 400 picometer they have given. We will keep that radius in picometer only. What is there? Right? So I will take it as picometer only. 4 into 100 it is. So root 3 is 1.73 into 100. So answer is 173 picometer. So answer is 173 picometer. This is numerical type of question, remember. Then 7th question. See, 1 mole of crystal of metal halide of the type MX with the molecular weight 119 having FCC structure with unit cell length 6.58 angstrom unit was recrystallized. So understand the question correctly. The density of the recrystallized crystal was found to be 2.44. After recrystallization, density is found to be 2.44. The type of the defect introduced during the recrystallization may be. So type of the defect, you can say additional M plus X minus Schottky defect, F center, Finkel defect. So here additional M plus X minus I answer the interstitial sites you cannot decide from here, or F center also. If F center, color should be there. But these two I can decide. How? Now you will calculate density by using edge length 119 and type FCC structure. You will calculate density by using this. Then they have given density. Then we calculated density and this density we compare. If it is more, if it is less, we will see that. Right? Which means first you have to calculate density. Density is equal to Z is 4 FCC into molecular mass is 119 divided by A cube. A cube means 6.58 cube into angstrom unit is there, 10 to the power minus 8 cube, so minus 24 into 6 into 10 to the power minus 20, so plus 23. That is our Avogadro number. Directly I have considered. So if you are not understood, you have to see that once again. Now, in this particular case, 119 into 4 is nothing but 120. 12 4s are 48. So I will write 480 divided by. Here, you can see 10 to the power minus 24 plus 23 means 10 to the power minus 1 is left. 10 to the power minus 1 is left. Now 6.58 cube. So how to calculate 6.58 cube? So for that, what we will do is, see, we know that 6 cube is equal to 216. 7 cube is equal to around 343. Correct? So 6.5 they have given, right? 6.5 they have given. I will consider it as 6.5 cube is equal to 300. Any doubt? So in between I will take 300, right? So 300 into 6. 300 into 6 is nothing but 1800. So 1800 I have written. Right? 1800 I have written. Now in this particular case you can say, so I will consider it as, remember, 18, 480 divided by 18, right? Because this 0 I will take it this side, so that it becomes, remember, 480 divided by 18 into 10 to the power, so minus 2, 10 to the power 2 minus 1, 10 to the power 1 it become, correct? Is equal to 18 ones are around, remember, 18 3s are 56, correct? So 54, 18 3s are 54, right? 54 less it is there. I will write it as around 2.5, right? 2.5, right? 2.5 into 2.6 also you will get it actually. 2.5 into 1825, actually 25 will get 2.5 and 10 to the power 0. So 2.5 gram per cm cube will get. So here 18 2s are, so 20 it is actually 25. 25 and 10 to the power 1, 10 to the power minus 1, 2.5 is equal to 10 to the power 0. 2.5 got. Here 2.5 and here 2.4. Correct? So 2.5 and 2.4, this density is more, this density is less. Then what is the meaning is this? After recrystallization, density decreases means which effect? Definitely it is a Schottky defect, because Schottky defect density decreases, hence the answer for this question is B. The net. At 100 degrees Celsius, copper has FCC unit cell structure with cell edge length is X angstrom unit. What is the approximate density of copper? So density formula once again, D is equal to, so they are given FCC 4 into this atomic mass also given 63.55 divided by here a cube, a is nothing but x cube. I will write x cube into angstrom unit is there, so 10 to the power minus 8 cube minus 24 into 6 into 10 to the power 23, you got it, correct? So now, so in this particular case you take it as 60 if I take also 60 into 4 224, so 24 means 240, right? 240 divided by, so x cube it is, x cube into 6, so into 10 to the power minus 1, so 6 ones are 6, 4s are 24, so 40, right? So 40 now is equal to 40 into 10 to the power 1 divided by, right? Minus 1 is there, I will take it as plus 1, 40 into 10 to the power 1, so divided by x cube, nothing but 400 divided by x cube. 400 divided by x cube is nothing but 422. Answer is D, like that. Total volume of atoms present in the FCC unit cell of a metal is, so FCC unit cell of the metal, total volume you have to calculate. So volume of one atom, we know that one atom is equal to 4 by 3 pi r cube. So FCC means how many atom? 4 atom. So volume of 4 atom is equal to how much? 4 into 4 by 3, right? So 16 by 3 pi r cube. 16 by 3 pi r cube. So answer for this question is D. The last question. Conduction in P type of semiconductor is increased by. Conduction is increased by what? So already P type of semiconductor it is. Increasing band gap, decreasing temperature is not possible. But adding appropriate electron deficient impurity, what it will do? It will create hole. It will create hole. That hole is responsible for the electrical current. Hence remember, answer for this question is C. Further, if you add electron deficient impurity, its conductance definitely increases, remember. So answer for this question is C. So these are the 10 questions I have discussed under JEE Main. I have selected it from Nta Abhyas app. I hope it definitely help you in your preparation. Thank you for watching. Have a nice day.